If you ever wanted to build real Solana applications but you don't know where to start, this series is for you. My name is Benjamin, and in today's video I will cover the different ways of interacting with the Solana blockchain. In the last video we connected to a Solana cluster, airdrops on Solana, and even ran our own local validator. This video is part 2 of the Complete Beginners to Advanced series, and we are going to cover the 2 fundamental ways Solana clients communicate with the blockchain using WebSockets for real-time subscription updates and HTTP methods for on-demand data requests. We will then put it into practice by subscribing to live account updates using WebSockets and use HTTP methods to send airdrops and confirm transactions. By the end of this video, you will understand how Solana applications stay reactive and also in sync with the blockchain, which is an essential concept once you are going to build real applications. And with that said, make sure to follow me on X and let's get started. Alright, so before we jump into the code, let's take a step back and see what it actually means to interact with the Solana blockchain. Now, in the previous video, we connected to a Solana cluster, and once you are connected, all the communication with that cluster happens through a JSON RPC API. And that is essentially a set of methods that is exposed by a Solana node that your application can call, and that node lives within that cluster. Now, there are 2 primary ways that this RPC API lets you interact with Solana, and they serve, of course, different purposes. The first one is WebSocket subscriptions, and WebSockets let you subscribe to a specific RPC method and receive updates or notifications whenever something changes. And this is how applications react in real time. For example, when an account's Lamport balance changes or a transaction is confirmed. The second is HTTP RPC methods. These are request-response calls where you can ask the node for data and immediately get the current state back. And HTTP requests are ideal for on-demand queries, of course, like fetching an account's balance or checking the status of a transaction. And of course, most real Solana applications, they use a combination of both, where WebSockets are there to stay reactive and HTTP calls are there to fetch the current state or confirm a state. Alright, so now that we know what the 2 primary ways are of communicating with the Solana blockchain, it's time to jump into our codebase, where we will recreate our wallet from a private key, and we are going to airdrop some Solana into that wallet. What we are going to do is set up a WebSocket connection, and we are going to listen for real-time account updates for that wallet, so we can immediately see when that airdrop happened. We're also going to use HTTP polling to confirm the airdrop transaction as well. And this way we can see how they can work together to stay reactive and also fetch data on request from the Solana blockchain. And with that said, let's check out the code. Alright, so this is our code base for today, and as you can see, there are many other topics that we are going to cover within this series. So make sure to subscribe so you don't miss any of the other videos. Also, all the code is available for download via GitHub, and the link for that is in the description. Now for today, we are going to focus on the index.ts file under interact with a Solana environment, because that is exactly what we are going to do. Just as in the previous video, we are going to make sure that our local cluster or local validator is running. And we can do that by opening our Solana CLI, which is running on the Windows subsystem for Linux. And once that is opened, we can start that local validator using Surfpool. We just have to start it by typing Surfpool start. So this will run that local validator, you could say local copy of the Solana blockchain, on our local machine. We can also check out the GUI by clicking on this link, and then we will end up in the actual Surfpool Studio. As you can see here now, our local cluster is running, and we have a local RPC URL and we have a local WebSocket connections URL. Now, before we are going to code and set up the WebSocket connection within our code base and also do the actual airdrop, I want to drive home the point one more time that there is a difference between these WebSockets and these HTTP requests. And if we go to the Solana documentation real quick, you can see under documentation, under API, they have these 2 types of methods here. They have HTTP methods and WebSocket methods. And we discussed this earlier briefly, but if we look at the getBalance method, what this does is if we send a request to that RPC URL and we send that request containing this body here where we ask the Lampord's balance of a certain wallet, it will return to us that information immediately. So we request that and that information is returned to us. Now on the other hand, we have the WebSocket methods, and for example the account subscribe. If we set up a subscription or we set up a WebSocket stream and then we subscribe using this method, we are going to get back account changes or notifications better when there are account changes for the account that we mention here. So this is the big difference. This is a stream that is continuously open and we subscribe to a method. And in this case, as you can see, there are many different methods, but if we subscribe to the method called account subscribe, every time there is a update for that account in Lamports or in data, we will receive that notification and that stream keeps open. That is not the case for the HTTP methods. Now, I want to show you how this works. So if we have, for example, Postman here, we have that local RPC running, remember? And what we are going to do now is get the information back for a wallet. Now in this code base, I have 3 wallets that I will use further along with other videos as well. But for this video, we are going to use the primary wallet, and they're also documented within the README file. So if you go through that README file, you can find all the information about the wallets that we are going to use. Now, for now, we are going to use the primary wallet. And if we check the balance for that wallet and we do the send request now, as you can see, there is no value because that wallet has no balance for now. And this is just the same body. As you can see here, we sent that request using this body, and that body is the one that we saw earlier, the get balance in the documentation. It's exactly this body here. We're sending a post request and we want the information for this wallet. As you can see, the value is 0. What we can do now is go back to Surfpool Studio and we can airdrop some SOL into that wallet. And if we say I want 10 SOL, we can send it. If we send that request now one more time, you will see that we get the state back for that account or that wallet, and we can send it multiple times. Nothing will change because we don't add more Lamports in it. As you can see, we request and we get an answer back. Now, on the other hand, what we can do is set up that WebSocket subscription. As you can see here, now we are using the WebSocket endpoint URL and we can connect to that. So now we are connected. What we then have to do, as it says in the documentation here, account subscribe, is send a subscription message to that connection or to that WebSocket connection. So if we copy this, as you can see here, and now we are going to send this message, and we're also going to mention our primary wallet. As you can see here, if we send this now, we get a confirmation back. So now we are subscribed to that method, listening for account changes for this wallet. Now, as you can see, this stream is continuously open. We don't have to request anything if the account balance changes. And I can show you that because if we go back to Surfpool once again, and we would airdrop once again 10 SOL into this wallet, you will see that we get that notification immediately. As you can see here, we got a new notification. And that is because this stream is open. It's continuously listening for changes for that wallet. And as you can see here now, we get all the information about what happened. So earlier, if we looked, we had 10 SOL. It is shown in Lamports, of course, but this is 10 SOL. And after we got back this notification here, we can see that we have now 20 SOL. So that is the main difference between these WebSockets connections, which are continuously open, and the HTTP requests, which are a one-time request and a one-time response. Alright, so now that we really understand the difference between these RPC requests and RPC subscriptions, the next thing that we are going to do is the exact same thing using Solana Kit. And as you can see here, the first thing that we do is create that connection, the RPC connection and RPC subscriptions connection, just as what we did in the previous video. Now, after that, we are going to recreate our key pair using our primary wallet. Again, we are going to use the same wallet as in the example before, and this time we are going to recreate that wallet from the private key that we have stored here under ID. And to do that, we have a function called load signer from file. Now, if you have a look at that function, you can see by default, it takes the pri.json private key. However, we can use this function and we can ask it to recreate the secondary wallet or the Benjamin wallet. And that's why we have this function here, because in the other videos we are going to use multiple wallets. For this example, we are only going to use the primary wallet. Now, what this function does is it takes the contents of that primary key and then it turns that into the bytes that we need to feed into the function called create key pair signer from bytes. And this comes with the Solana Kit SDK. This will return to us, as you can see here, a key pair signer, and then we are going to store that in key pair signer and eventually return back to our main script, as you can see here. So now we have the wallet, or the key pair better, containing our public address, which is the primary address here, as you can see, the same that we used in the example before. What we are going to do next is set up a abort controller, and this abort controller is just a mechanism that we can use to stop our subscription stream. As you can see here, the next thing that we are going to do is set up that RPC subscription. Now, as you can see, we are using Solana Kit. Also here, account notifications, it comes with that RPC subscription that we created here earlier via the Solana Kit function, create Solana RPC subscriptions. And that exposes to us a method called account notifications. Now, under the hood, if we look at that, this does the same exact thing. As you can see here, it even references the Solana docs. So if we click on that, as you can see, we are going to the actual documentation, and here it says account subscribe RPC method, and that is the method that we were looking at earlier, as you can see here, for our WebSocket, the account subscribe method. So under the hood, that logic, of course, is extracted away. That is what Solana Kit takes care of. However, we are going to use the same exact subscription under the hood. And what we provide here is the wallet address from the wallet that we recreated. Remember, we set a commitment level, and we can also, once subscribed, add a abort controller by setting the abort signal, and then we are going to use that abort controller and we are going to send a signal once we want to abort it. Now in this case, we are going to abort our WebSocket stream once we confirmed that airdrop that we are going to do. And that's what we do here. So next we are going to asynchronously listen for these notifications that come through. So these notifications, they will be caught by this stream here, and then we are going to loop through these notifications, or we are going to wait for these notifications, and once we receive them, we're actually going to output them in our console, as you can see here. So we're console log that we received a new notification, and we're also going to extract the wallet balance from that notification. Remember, because a notification, it looks similar to this, and it also includes that wallet balance. As you can see here, under value lamp ports, we have the exact amount of lamp ports, and that's what we do here. Under value lamp ports, we can extract that number and then divide it by the amount of lamp ports which we have stored in our config file, and this is just the lamp ports per SOL that we use to divide that value, and then we get the actual SOL balance of our wallet. Now next, what we are going to do is create a airdrop request. Remember, we also have to airdrop Solana into that wallet, and we can do that by using the RPC connection that we created here earlier using the create Solana RPC. Also, that comes with Solana Kit, and that exposes us a method called request airdrop. We're going to provide our wallet address once again, and also the amount of lamp ports that we want to airdrop into that wallet. Remember, we can use lamp ports and then specify the lamp ports per SOL, which equals to 1 SOL, and we do that times 10, and we write it like this because it's a big integer, and then we are going to send that. Now then we are going to get a airdrop signature, and what we are going to do with that signature is see if we can get a status from that using a HTTP request. Because remember, we are going to try to catch that notification that comes through the subscription stream. And if that is the case, then we are going to abort and our function or our script will end. However, we are also going to poll for the status of that signature. And that is what we do here. So we're going to use that RPC connection and use the method that is exposed by this connection called getSignatureStatuses. Then we are going to provide the airdrop signature. And then we are going to extract the value and the confirmation status from that signature. Now, if that is confirmed, then we are going to output the airdrop status is confirmed, and we are going to break from this. And otherwise, if it is not confirmed, then we are going to rerun this once again. And this means that this will keep running until the airdrop is confirmed by our RPC request. And that is what we do here. So we are not using the subscription. This time we are using the get account info or get signature. It's a slightly different request that we're doing because we are going to check the signature, but also this under the hood, as you can see here, is a RPC get signature status request. So if we look at the Solana documentation once again, now we are under the HTTP methods. Before we looked at the get balance, now we are looking at the get signature status. So we can request all kinds of information using these HTTP requests. Before we requested the balance, now we are going to get the status of a certain signature, and that's what we are doing here. So under the hood, again, Solana Kit extracted this logic away for us, but it does the exact same thing. We are going to get the status of that signature, and we are going to extract the status. If it is confirmed, we output it in our console, and then we break out of this while loop. If it is not confirmed, we keep looping until we get that confirmation. And if we run this, now if you look at the package.json, just as with the previous video, I created a script that we can run, and this will trigger the index.ts file here under interact with Solana environment. So we need to make sure that we keep this one running in the background because we are using this local cluster. And if we go back to our PowerShell instance and we type here npm run 2, that will do the exact same thing as we did before. And as you can see here, we get that WebSocket notification, we get the Lampord's balance, which is now 30 because we airdropped 20 into it earlier, and we get that confirmed message. So we know that also this setup properly works. We do the actual connection, we recreate our wallet, we set up the stream. Once we have the stream, we listen for notifications, and then we do the airdrop. And with that signature from that airdrop, we are going to poll continuously for the status of that signature, and if that is confirmed, then we end our script. And also here, once that notification comes in, we are also going to output that, and that is what you see here. So we get that notification including the new Lampord's balance, the Lampord's balance that we output ourselves, and also the confirmation from that signature. So this is how we can use these HTTP requests and also RPC subscription streams to make sure that we stay reactive when changes occur, and also that we can get the state or the data for certain information whenever we want by sending that request. Alright, so that was it for this video. I hope you now understand the differences between these WebSockets and these HTTP requests, and we also completed the task for this video. In the next video, we are going to check out Solana key pairs, and we are going to touch lightly on what it means to be on curve, that we will good to understand later once we are going to look at, for example, program-derived addresses. That's it for today. Remember, all the code is available via GitHub. I hope you think it was interesting, and with that said, I'll see you in the next one.